right, so today we're going to be shifting gears a little bit and adding on to the knowledge you already have, but applying it to a new idea. Okay, so now we're going to be talking about the unit circle. This is a big buzzword and trig. Okay, honestly, the unit circle, it's kind of a weird thing. All right, so just bear with me whenever you first start to see it, because we start pulling equations from it seems like nowhere and starts making all these statements. But I really want you to think about the truth of the statements I'm making, not where are they coming from. Don't care about where is it coming from, but care more about how does it work. Okay, that's what I want you to think about when we're talking about the unit circle. So a unit circle, you should have already written this in your Words Worth Knowing, is a circle with a radius of 1 where the arc length is always, this should say equal to the corresponding angle measure in radians. So let me say that one more time. This is a circle with a radius of 1. All right, so there's my little radius, where the arc length is always equal to the corresponding angle measure in radians. So what I'm saying is, if the arc length out here is 15 units, then inside the measure's 15 radians. Kind of trippy, okay? But that's the way a unit circle works. I'm going to explain why in a second, but that's what it is. So now, if you go ahead and open up to what is a unit circle, on the left-hand side, I'm going to describe just that to you, okay? How it works. How what I just said can possibly be true. Okay, so first of all, some things about the unit circle. The radius is 1. That's why it's called a unit circle, 1 unit. That's how big the radius is. The center is always at 0, 0. So we need to draw a coordinate grid here to our circle. So center is at 0, 0. And if we have a point on our circle, let's call that point XY, then we can make a statement about X, Y, and R. We just learned 2 lessons ago that in a circle on a coordinate grid, x squared plus y squared equals r squared. Do you remember that? Hopefully you do. So here we have an equation for this circle. The equation is x squared plus y squared equals 1. Because I told you in a unit circle the radius is always 1. So here, no matter what your points are, when you square them and add them together, they have to equal 1 or else they're not part of the unit circle. Okay, so stay with me. We got that equation from 2 lessons ago, maybe 3, where we talked about the relationship between x, y, and r and how they relate to trig functions. But here, we're going to use this information as part of what we know about the unit circle. So, we know these 3 things. Now, I'm going to prove to you how I can make the statement that the arc length is equal to the angle measure in radians. Way back when, we learned a formula for arc length, and that formula for arc length was S equals the angle in radians times the radius. That was the formula that we came up with. Well, in the unit circle, R is always 1. So in the unit circle, S equals theta in radians. So arc length equals the angle in radians. There's my proof. All we did was use this formula and say, oh, well, the radius is 1, so arc length equals the angle in radians every time. So no matter what your arc length is out here, it's always going to be the same as the radius in here. Okay, so I'm sorry, I said that wrong. The angle measure in here. And in your textbook, they keep using T to refer to that. So T is how long your arc length is, but it's also how big your angle is in radians. It's kind of trippy, okay? But it's just a unique property of the unit circle that we can use to solve problems. So now let's actually solve a problem. All right, so let's make this circle part of a coordinate grid, and this circle is a unit circle. And given P is a point and equals -3/5, comma -4/5, find sine of t and cosine of t. So now they're going to start using t instead of theta. I don't know why, but we need to be versatile with our thinking. So I'm okay with changing what our theta is. So now we're going to call it t. When we're in the unit circle, we're going to call our angle t. So let's go ahead and plot this point, -3/5 and -4/5. Okay, well, let's divide this into 5 parts. Yours may not be as pretty as mine. I'm pretty good at eyeballing stuff. So -3/5, -4/5. It's going to be like right there. So there's the terminal side of our angle T. Okay, so now we need to find sine of T and cosine of T. Notice they're not asking us to find arc length or anything like that. They're not even asking us to find how big the angle is. All they want us to do is find the trig ratios for sine and cosine of T. Now, how do we do that? Well, we were given a formula in a coordinate grid for sine and cosine. That was 2 lessons ago. If you flip back in your ISN, it was on page 29. Whatever our x, y, and r were allowed us to find the trig ratios. Well, that's what we're going to do right here. We have x and we have y. And we know r is always 1. So we can actually draw a little triangle here. All right. I'm not going to write in the values because it's a little cramped. But to find sine of t, I'm just going to say, okay, y over r. Well, when you divide something by 1, it just equals itself. So basically, sine of t equaled y. And the same thing's going to happen with cosine. Cosine of t equals x over r. So we're going to do -3/5 over 1, which is just going to equal 3/5, which means cosine of t basically equals x. Okay, so that actually leads us to something very profound. Let's go ahead and do tangent just to see what happens. Okay, so tangent of t equals, and we're going to do -4/5 all over -3/5. Okay, because it was y over x. Now, hopefully you guys are starting to notice that when you have complex fractions, you can just flip it over with tangent and the hypotenuses are going to cancel. So it comes to 4/3. If you don't understand that, you can go ahead and write in the middle step, but I'm not going to. So that's what tangent is. Nothing too profound there. Okay? But these two are kind of weird. Sine of t equaled y and cosine of t equaled x. And the thing is, that's always going to happen. So now we're going to fill in the bottom half of our foldable. Trig functions for the unit circle. So it turns out that if you're working in the unit circle, we can actually simplify these formulas down a little bit. Everywhere where there's an r, we can just put a 1. Okay, so that's what we're going to do here. We're going to say, okay, let t be a real number, no imaginary numbers here, and p equals x comma y be a point. Then, oops, I'm writing sideways, sorry. You're probably getting vertigo. Then we know that sine of t equals y, which means cosecant of t equals 1 over y. Cosine of t equals x, which means secant of t equals 1 over x. And lastly, tangent of t still equals y over x, and cotangent of t equals x over y. So it just simplifies our formulas a little bit from what we had, if you look here. And notice the same rule applies, that x and y can't equal 0. Because if we did, we'd have a 0 in the denominator. But so those are kind of revised for the unit circle. Now go ahead and glue that in, and I'll give you guys practice problems.